Hello students, today's topic is kinematics. So before we go to kinematics, let us try to see what kinematics is and where it is derived from. So basically the part of physics where we are dealing with any moving object or any kind of movement is called dynamics. Dynamics is further subdivided into two parts. Means here we are saying the study of motion, means dynamics is being divided into two parts. First is the study of the reason behind motion, and the second, or say the description behind motion, and second being the causes of motion. And the description of motion is known as kinematics, and the reason behind motion, means suppose force, momentum, these kind of things which are responsible for any kind of motion is known as kinetics. In kinematics we will see the description of motion like position, distance, displacement, speed, or say velocity, these two are different things, acceleration. Before we go and study all these aspects of motion, or say parts which are used to describe motion, we need to know what motion is. You would have studied in earlier classes that motion is the state of being able to change their position with time. So first thing we need to define is position. To define position, we need to know to which thing we are comparing to. Like say this is point A, this is point B, and I moved from point A to point B. So how will I say what is point A and what is point B? Consider this plane as an XY plane where this direction is X direction, say horizontal direction is X direction, and vertical, or say the way my front direction is Y direction. So from going to A to B, I'm moving in a X direction, and here I am saying this is a post, and the distance of point A is 5 meters. So I will say that point A is at a distance of 5 meters towards X direction or in the X direction, and then say the distance from A to B being 7 meters. Using simple mathematics, we can say the distance of the post to the position B or the point B is 5 plus 7, 12 meters. So in this case, what we are doing, we are referring these points to a reference, and in that case our post is a point of reference, or say a frame of reference. A frame of reference is any kind of frame to which we relate any kind of motion or any description of motion. So here in moving from A to B, we would say we moved 7 meters in x-axis. if we are describing 7 meter in x-axis or any kind of motion in x-axis, say this is a point C which is in the y direction and is 5 meters in the y direction, and I moved A to C. So my motion is movement from A to C, that is 5 meters towards y direction. Suppose I simply remove y as north, I renamed it, and x as east. I would say A to B is 7 meter east, and A to B is 7 meter east, and A to C is 5 meter north. And if we are considering the change in motion, say I moved from A to C in 1 second, it is 5 meter towards y-axis in 1 second. Then our speed equals to distance by time, that is 5 meter by 1 second, or 5 meter per second. Similarly, if I have taken 2 seconds to move from A to B, my speed would be from A to B would be 7 meter, and I said I have taken 2 seconds, that will give me 7 by 2 meter per second, or 3.5 meters per second. So we just considered 2 parts of kinematics. First, distance, and second, speed. And how do we relate it? Let's say distance is given as d and speed as v. V equals to d by t, distance by time. If we are moving in a single direction without changing our direction towards left or right, just moving ahead, and might be moving back without getting turned or something, this will be called one-dimensional motion. Why one-dimensional? Because there's only one dimension involved. Like you would have seen, dimension could be length, width, and depth. If we are moving in only one direction, that is in one line, our motion is one directional. If our motion is something like this on a paper, this is a two-dimensional, 2D or two-dimensional. Two-dimensional motion. Similarly, if something is flying, something that can move in height, go into depth, like when we are swimming or when a bird is flying, this is a three-dimensional motion. So let's go ahead and see what is how do we describe speed in graph, say graphical presentation of speed. I would say graphical presentation of any kind of motion, not speed, any type of motion. Suppose this is a point which would I say home, to another point which I said market, and then I reached my friend's home. All these points being on a straight line so that we are not required to change our direction. From home to market, this is 5 kilometers, and from market to my friend's home, that is 10 kilometers. And I'm taking 30 minutes using my bicycle to reach from home to market, and then say 40 minutes, or say 60 minutes. That is one hour from market to my friend's home. So let's try and make a graph of this motion. In the x-axis, I'm taking the time, and on the y-axis, I'm taking the distance covered. Let's mark it up. All these markings here on the vertical axis is in kilometers. So 5 kilometer, 10 kilometer, and 15 kilometer. At time equals to 0, I'm at my home. Let's mark our time as here 15 minutes, 30 minutes, 1 hour, and again. It takes me 30 minutes to go from my home to my friend's home. So at the 30th minute, I'm at my friend's home, that is 5 kilometers from my home. Then after 60 minutes of that, I covered further 10 kilometers. So 5 kilometers to 10, 15. I have covered a total of this is our position time graph. We know two positions here. We don't know in this duration where were we, or where the bicycle was, so we cannot say, but based on these two marks, we can say that if our speed is constant, or say the rate of change of distance or the rate of change of position have remained constant, this will be the graph. And the average speed is the slope of this graph. What do we know about the slope of this graph? If the angle made with the x-axis is theta, then the slope of this graph would be tan theta. And how do we measure tan theta? Tan theta equals the perpendicular distance, or say the opposite side by the adjacent side, or the base. So here the average speed is given by the net slope equals the distance covered, or the perpendicular distance here, or say the total distance covered, divided by the base. This base is the total time, so here we reached our formula: average distance equals to total distance by total time, using the graphical method, using the graphical presentation of distance versus time. Let us try and work another the same example and try to plot another graph. And this time we are not plotting distance but speed. We know that in 30 minutes we have gone 5 kilometers. So using the formula of speed equals to distance by time, we can simply say speed equals to 5 kilometer by 30 minutes or half an hour. Solving it, we get 10 kilometers per hour. So I would say for this duration, this is 10, 20, 30. The average speed has been 10 kilometers per hour. And for the next 60 minutes, again 10 kilometers has been covered in 60 minutes, that is 1 hour, or 10 kilometer divided by 1 hour, again we have 10 kilometer per hour. So our speed time graph becomes a straight line which is parallel to the x-axis. Suppose our speed has been increasing continuously. Say at minute 1 it was something close to 0, then it came to be it was accelerated, and then the speed increased, and so on. It kept on increasing. So this could go on, and our speed time graph would be a graph with an increasing slope. An increasing slope means the quantity here depicted on the y-axis is increasing, like we just did earlier. Here distance was continuously increasing in the graph. This was the distance time graph, and that's why, since the graph was increasing, we have a constant slope, constant positive slope. Another thing, let us relate distance time graph with speed time graph. You see, the slope here is theta, the slope here again is theta, because it is a constant slope. The slope has not changed, and we know the slope of a distance time graph gives the average speed. That means the average speed for these duration, for 0 minutes to 30 minutes, and for 30 minutes to 90 minutes, this has been the same. Now let us go and try to see how a distance time speed time graph can be interpreted into a distance time graph. suppose I started moving at a speed of 20 meters per second. This is a quite high speed, so let's change 2 meters per second for about 10 seconds. Then we increased our speed to 5 meters per second for again 10 seconds, and then 10 meters per second for 10 seconds. Let us try and mark it on our speed time graph. Our speed time graph would look like discrete lines from 0 to 10 here, horizontal line, from then again 10 to 20 another horizontal line, and 20 to 30. This is because the line have been discrete, because we are saying we are getting abrupt changes in our speeds. Now let us try and locate this, represent this information in a distance time graph. So distance time. Consider the first part, the distance covered equals to v into t, that is 20 meter. Distance in the second part, 10 times 5, that is 50 meter, and in the third part, that is 100 meter. Without looking at this data, let's try and consider only this part, whatever information is stored in this graph, and interpret the same into a distance time graph. Initially at 0 our speed was 10, so obviously we are increasing from a 0 distance, so we'll start from here, and there's a constant velocity because the line is horizontal, so our speed our distance will look like a straight line but with a constant slope. So the slope will be 2 meters per second, so something like that. This thing divided by this thing should be 2, so this will go 20 times. It will go something like this. Similarly, in the next part, this from here to here, this part should be 5 times of this part, something like this, and so in the next part it will be again going up. Means you are seeing that the theta or the slope is continuously increasing because the speed is increasing. So we establish speed, or say average speed, is equal to average slope of distance time graph. Similarly, we'll come to know that when we are talking about instantaneous speed, our slope will be instantaneous. What is instantaneous speed or average speed? Like you traveled from your home to your school. You might have moved with a constant speed, or you might have moved with a up and down speed, say increasing or decreasing speed. So if you have traveled 5 kilometers in 30 seconds, your speed is definitely 30 meters per second, but sorry, that is 10 kilometers per hour. But if your speed has not been constant, you would have sometimes your speed is 20 kilometers per hour, and sometimes you might have increased it to 40 kilometers per hour. So one way where we are describing distance time graph, one way it is a constant speed, another way it is increasing and decreasing. So whenever you see a curved path or a curved distance time graph, you would say that the speed is not constant, or say variable speed. If the slope is constant, the speed is constant, and the slope is varying, then the speed is variable. Now we get to another concept related to, or say incorporated into kinematics, is acceleration. What is acceleration? Acceleration is the rate of change of velocity. Before we go to velocity, let us try and understand what is the difference between velocity and speed. So the basic difference is speed is a scalar quantity and velocity is a vector quantity. Vector quantity is any quantity which has direction as well as magnitude. And speed, being a scalar quantity, it only has magnitude, while it has no direction, or say its direction is not important. So if we are moving from A to B and then to C with 5 meters per second constantly, we would say the speed is constant, because speed, the magnitude has remained the same, but the velocity is not the same, because earlier it was moving in y direction, now it is moving in x direction. So velocity has changed, so we can say constant speed but variable velocity. And when we say there is a variation in velocity, we would say we would have rate of change of velocity, and rate of change of velocity is nothing but acceleration. So simply we would say acceleration equal to rate of change of velocity, and this is average acceleration. When if an object has speed or say velocity 20 meters per second at t equals to 0, and then velocity changes to 50 meters per second at t equals to 5 seconds. We'll find out the average velocity, average acceleration as change in velocity by change in time. So change in velocity is 50 meters per second minus 20 meters per second divided by time. 5 seconds minus 0 seconds. We are getting 30 meters per second by 5 seconds, and our answer is 6 meters per second square. So here we calculated our average acceleration. In the same way, we may get to find instantaneous acceleration. Instantaneous acceleration, for that we would need to find very small change in velocity and time. So that would be given by delta v by delta t, while delta t is almost 0, and this thing is called derivative of velocity with respect of time. So that gives us the formula A equals to dv by dt. You will come to know about this concept once you will get the basic understanding of calculus. So consider the the type of motion where acceleration is constant. When acceleration is constant, we call that kind of motion as uniformly accelerated motion. And there A is equals to a constant, or say A is not changing. In that case, if we are saying A is not changing, that means acceleration is equal to average acceleration is equal to delta v by delta t. Or in simply, if delta t is simply as t, we would say final velocity minus initial velocity by t. Changing the same equation, we are getting v equals to u plus at. We can also find this formula using a graph. So let's draw a velocity time graph. We just said that acceleration is constant, so our rate of change of velocity is constant. Therefore, the slope of this graph, velocity time graph, would be constant. Consider the time t1 and t2. At t1, the velocity is u, and at t2, the velocity is v. That is, the initial velocity is u and final velocity is t. Considering this thing, the time duration from t1 to t2, t2 minus t1, we are taking as t, which is the time here. And we are finding v in terms of u, a and t. So we can say, we can draw a rectangle here. We know this distance is u, this distance is u, and this whole distance is v. So the part here, this part is equal to v minus u, and this thing is theta, or say tan theta, which will be equal to v minus u. Simply slope equals to v minus u divided by t2 minus t1, or t. And we know that the slope of any velocity time graph is acceleration. Relating the two, we get v minus u equals to at, or v equals to u plus at. We derived the same formula using velocity time graph, v equals to u plus at. Now we are describing distance, and we are finding distance using a velocity time graph. So summing up first, we'll say for any duration from t1 to t2, the distance can be calculated by the area, by measuring the area under graph of its velocity time graph. Please note that this is a velocity time graph. We don't need to use distance. If we are finding using a distance time graph, then simply marking the point onto y-axis, we find the distance into anything, for any instance of time. For suppose t1, this is d1, this is. But if we are working on velocity time graph, we'll come to find distance by measuring the area under graph. Okay, so again, when we are working with uniformly accelerated motion, we would find the area of this part to find the distance covered from time t1 to t2. And we already discussed, we are marking t equals to t2 minus t1, and here this shape is of a trapezium. You say two parallel lines here and two non-parallel lines. We know this distance, this is the base of the trapezium, which we know as the final velocity v. This is the top part of the trapezium as u, and this is the height of the trapezium, t2 minus t1, as t. So the distance covered is equals to area under graph equals to u plus v, sum of the parallel lines, into height by 2, or ut plus vt by 2. we already know that v equals to u plus at, ut plus u plus at by 2 equals 2ut plus half at square by 2. That is giving us ut plus half at square. So summing up our work here, this is distance equals to ut plus half at square, which we found using a graphical presentation method. Let us consider any kind of motion that is not strictly into one dimension. Suppose it is suppose you throw, or you are shooting an arrow, you are throwing a stone into air, and you are throwing that air at an angle theta with the ground with velocity v. How do we know that? How will it move? By experience, you know that the motion of this projectile or whatever you have thrown or shot will go like a parabola. Why this goes like a parabola? We can find this out by resolving the velocity and working the kinematics equation on that. So let us go ahead and work on that. So the horizontal part of the velocity, or say the horizontal component of velocity, is this is the horizontal component that we will find v times cos theta, and the vertical part is v sin theta. Now applying the vertical, applying kinematics in the vertical motion of the projectile, we know that vv being the initial velocity, and we also know that at the top the vertical velocity will be 0. That is why it is coming down. So applying the speed kinematics formula, v equals to v equals to u plus at, we are going to find the time at which it will reach the maximum height. So t equals to v minus u by a. What is v? 0. What is u? vv, or vertical velocity, that is v sin theta. And what is a? A is acceleration which is acting downward. By convention we will take it as minus g. So the time taken in reaching the highest point will be v sin theta, or say minus v sin theta by minus g, or v sin theta by g. Now we know that in going into to this height we needed v sin theta by g. So by symmetry we know that the same time will be taken. Time to go up is equal to time to go down, v sin theta by g. So total time of flight is 2v sin theta by g. So we are taking time of flight equals to 2v sin theta by g. We'll work out more on this topic in some other videos. You can always go and download videos relevant to this topic from toppr.com. Thank you.